Hey everybody, hope you're doing well. Today I wanted to go through the brand new model series that OpenAI just released. They released some brand new models with new capabilities. I want to walk through what their documentation looks like, what they're used for, and then a couple of use cases where these models are now preferred over some of the other models that they offer at the end of the day, as well as some of the other models that are on the market. So we're going to go through everything that they have put out about this. I'm going to give my thoughts, my feedback, everything like that. I want to remind everybody, we are growing our Discord group for engineers and data scientists. Please hop on and join. The link is down below. We're helping people every day build products with things like this and are always looking to add more people to it to help them as well. So sharing my screen here, this is the initial site that they have put out around these new models. I received an email a couple days ago saying that these were available. I believe it's available to everybody that has a paid plan with the platform. If you have a paid plan, you should have access to it, which should be a lot of people that are already using these models. So the OpenAI O1 series models are these new language models with reinforcement learning to perform complex reasoning. So all the models are focused on being able to solve tasks that other language models struggle with. They have more reinforcement learning, meaning that they were able to go in and try to fine-tune these models on more of a step-by-step approach. An example of that would be if you put in some instructions to write some code and it generated the code, and then instead of just training the model on just that, you train it on the user going, no, I don't like this. I want to, try again. Or no, I don't like this. It shouldn't be this. The model tries again. You provide feedback. And so being able to kind of go through those steps and go through that sort of reasoning to reach a correct result is what a lot of the focus here was in this sort of training style. I'm sure they did some other sort of chat style training, like chatbot style stuff. You see that very common with reinforcement learning as well as I'm sure they used a lot of chain of thought. We'll talk a little bit more about that down below because they do mention chain of thought in the way that these models work. But kind of want to take a look at some of the high level stuff here. They mentioned that the models excel in scientific reasoning, ranking in the 89th percentile of competitive programming, placed in the top 500 in the USA Math Olympiad, and are exceeding PhD levels on a couple of different other benchmarks they put out there. So the understanding and ability to sort of evaluate and process through tasks is a huge part of these models. Really focused on some of the stuff around math and code and reasoning that is much harder, and that people have tried to build entire frameworks around solving. You see things like tree of thought, chain of thought, different things like that. All of those prompting frameworks are built to try to do this reasoning with models that didn't have these capabilities built in. They do mention that although it offers a significant advancement in reasoning, they are not sort of a now one size fit all for everybody's use case. You'll see down below, they don't support image inputs, they don't support function calling and things like that. So this really is just focused on the reasoning portion of things. You'll see this in our test, but they'll mention it as well. O1 models are much slower. They have to go through these reasoning steps by themselves. So if your model doesn't need reasoning because of the use case, why go through that? Why use those extra model runs and everything like that if you don't need it? So they will mention that because of some of the speed and some of the image and input constraints that these models have, not all use cases should hop right over to this new model. They do mention that this is a beta model. So, some features might not be there, some access might not be there. That's why I mentioned it sounds like there's some specific stuff that limits people's access and stuff like that. I have access on my personal and company plan, so I'm guessing a lot of people have that as well, but they've put in some rate limits and things like that. This is a beta, so they're trying to get some feedback, trying to see how people use it, everything like that. very straightforward on how the actual models work. Nothing here looks any different than kind of the standard, usage of models like GPT-4 and GPT-4o mini. You have a user, you have your input content, you have assistant, you have system, different things like that. All of that very standard and straightforward. I did want to mention that they currently have 2 versions as well, just like we've seen with some of the other models where they do a sort of standard size and then a mini. Very standard approach at this point with OpenAI. You're seeing some other models do that as well with different sizes. So they do have both of those available. Couple limitations that the beta currently has. Text only. I'm not surprised about that. They're only using assistant and user messages right now. They're not using system messages. That's kind of interesting. I wonder if that's going to stay, because if you had system messages, at all, why would you not include them in a beta? I mean, it's just another part of the prompt. So maybe system messages don't exist at all in the O1 model series. Streaming is not supported. That's not a huge it's not a huge ask. That might change. I would actually be surprised if that didn't change when they move to full production, because streaming in a production setting is much more useful than it is in something like a beta, thing like that. Tools aren't available. It's a beta. I'm not surprised. Log probabilities are not supported. They're not going to be supported in production either. OpenAI has made it very clear that they do not want to support log probabilities. There's a whole lot of reasons I believe that they do that for, but I'm not going to go into that today. A couple other variables are sort of general temperature and top P and different things like that are just set. You can't play with them at all, and you'll see that in the playground. It's a very simple UI, very simple approach. And then assistants and batch APIs are not available. Like I said, this is a beta. We're just trying to stick to the sort of very important stuff, allow people to play with it, gather feedback, and then hopefully they'll use that going into production. So I want to dive now into the reasoning portion. So the entire goal of these models is a new level of reasoning, new level of ability of being able to self-reflect and think on your outputs and your inputs and be able to go from there. So O1 models introduce reasoning tokens. So these are tokens used to think, breaking down their understanding of the prompt and considering multiple approaches to generate a response. That sounds incredibly similar to things like tree of thought. So if you've seen our, the video we made on it, and you've read some of the articles around it, tree of thought takes a similar approach where you generate multiple different approaches of completing the task, and then you follow the path that makes the most sense based on some sort of feedback loop. Very similar to like a decision tree or something like that. So that sounds a ton like tree of thought. After generating reason tokens, the model produces an answer of visible completion tokens and discards the reasoning tokens from its context. I don't know why they call these reasoning versus completion tokens. I guess it's just a naming convention, because on the back end, they are the same. The reasoning tokens are still text. They're still, some sort of information that's trying to solve the task. I guess it's just because they don't display them that's why they call it that. I don't know. That's a little bit different from a naming convention standpoint. Here's an example of a multi-step conversation between a user and an assistant. Input and output tokens for each step are carried over while reasoning are discarded. So very standard. You have your input. Some reasoning steps are taken by the model to try to solve the task. And then there is output, and you can keep going and going and going. If you put in another input, you do reasoning, you go to output, input, reasoning, output. You can keep going from there, but it's showing that at each sort of step, every time you put in input and you hit go, before you get to the output step, you have some reasoning that goes on there in the background. Anything else worth looking at here? No, they did mention here, I mentioned speed before. They even note here that these requests can take much longer. That's due, of course, to the nature of having to generate this reasoning, generate the chain of thought, generate some of the steps that are taken. And so they mentioned it can take a few seconds to several minutes if needed. One of the things that's kind of interesting now is, you think about all these tokens being generated in the background. That makes the context stuff very weird. If you have ever worked with chain of thought or tree of thought, where you are manually generating, the thought bubbles, or you're manually generating, the tree of thought to solve the task, you have to manage the context tokens on your own. There's no, terminology called reasoning tokens or something like that. They're just tokens, and you have to manage them yourself. So I'm kind of interested to see how they handle this here. It looks like they offer a context window of 128,000 tokens. It's fairly standard at this point with all of their models. Each completion has upper limit on the maximum number of tokens, including those visible reasoning tokens and visible completion tokens. So that the token window, the context window of the tokens includes both the whatever reasoning tokens are needed, and you don't really get a say in that in terms of like, here's what I have. They just get generated as you go from there. And then you have your output tokens as well. Both of those are included in that context. Very important to note that, as you'll probably see, some tasks that are more complex take more tokens to reason than you might expect. So that's something to keep in mind there. It's important to ensure there's enough space in the context window for reasoning tokens when creating completions. Depending on the problem's complexity, the models may generate tokens from, that's just what I said, where, based on how hard the problem is, you don't really know what that's going to look like when you go from there. Exact number of reasoning tokens used is visible in the usage of it. Okay, cool. So they do show you how many are used. They have a nice little usage thing here. I've seen this before. Or they show you like, how many tokens are taken up in the prompt, how many are in the actual completion side, and then what went on there in the middle of the reasoning. So that's very nice to see. Controlling costs. So I'm not surprised they included this. This is going to be a big question around it when you sort of run some of these more automated systems that are generating stuff based on some sort of plan, and that plan is dynamic. You don't have as much control over your costs. So I'm interested to see kind of what they do here. To manage costs for the O1 series, you can limit the total number of tokens the model generates using max completion and previous max tokens. Control both the number of tokens generated and the number of tokens visible, which were always equal. Okay, yeah, so they made a max completion tokens, which replaced max tokens. So max tokens, because we didn't have reasoning steps in the previous versions, was just how many tokens do you want to maximize your output to have. Now that you have kind of both of these, you need to segment the max completion tokens and be able to say, this is how many tokens I can have in my completion. Now that you do need to leave some room there for the reasoning side of things, but that control is nice that you can sort of maximize what you have there. Specifically control the number of tokens generated by the model, including both reasoning and visible completion. Yeah, so if you know how many tokens you have total, and you say 400 of them, let's say you have 1,000 tokens total, and you say 400 is the maximum for completion, then you're saying 600 is the maximum for reasoning. That makes sense. Max tokens parameter functions the same for previous model school. If generated tokens reach context limit or the max token you set, you'll receive a chat completion response with finished reason set to length. This might occur before any visible completion tokens, meaning you could incur costs for reasoning, input reasoning. Yeah. So just to make sure, you're really going to want to feel confident in this use case from a testing and development standpoint, because you really need to make sure that you have the size of your outputs down and you understand what that looks like, so that you can leave enough room for the reasoning, because you'll end up with situations like this where, like they said, you have your cost for your input, and then you have your length for the reasoning tokens, and you don't get a response back, and nothing actually went wrong. You just ran out of tokens. Let's say you had 100,000 tokens in your input, and the model decided it needed 8,000, 28,000 tokens for reasoning. You're not going to get anything back, and nothing actually went wrong. You just didn't structure the size of your equation in a way that makes sense. And the way to sort of fix that is through testing and development. you need to get a gauge of what the average tokens is in your completion, the average tokens in your prompt, everything like that. You just need to feel comfortable with those variables. If you've ever done any sort of price analysis with OpenAI for you or for customers, you're pretty familiar with that anyways, because they want to know, what this stuff costs. And so you have to calculate the size of the prompt and calculate the size of the average output. So nothing there really changes at that point. Recommends reserving at least 25,000 tokens for reasoning and output when you start experimenting with these models. Yeah, and they even say, as you become familiar with the number of reasoning tokens your prompt requires, you can adjust this accordingly. Yeah, I completely agree with that. 25,000 is pretty big. That means your prompt has 100,000 tokens in it. It's a pretty big prompt. I don't know what your use case is, but that's pretty large. But anyways. Let's see their advice on prompting. I'm kind of interested to see what they give here. These models perform best with straightforward prompts and prompt engineering techniques like few shot prompting or instructing the model to think step by step may not enhance performance, hinder it. One of the things I don't love reading the O1, documentation and things like that so far is I don't know what the reasoning looks like. I don't know what you're doing. And they're probably not going to give us that. I mean, why would they? Competitors could steal and stuff like that. I would like to know what sort of reasoning they're doing. Chain of thought, tree of thought, plan and execute framework. That's one that I really love. Understanding what framework is being used and how that framework works is very important to make iterations, make optimizations, have control over the software you're building. This is just adding another step that I don't really know what goes on. It's just some sort of magic box that happens. So I don't really like that. So when they say things like, hey, I don't need few shot prompts, or I don't need to instruct the model to think step by step, why? Like, did you build, a chain of thought prompt in the back end? Are you generating few shot examples in your prompt like on the fly as a part of the plan? Like I don't know what you're doing. And so it's kind of hard for me to make decisions if I do things like that or not, or take that sort of suggestion, straightforward, because I just don't know what you're doing. I mean, I don't know what the software is actually doing in the reasoning steps. So that is the one thing that I kind of don't like. I don't know. It's just something that I thought about sort of going through this. Keep prompts simple and direct. Clear instructions without need for extensive guidance. Why can't I do that? Is it overlapping with something you're already doing? Is it just fine? Is it just reinforcement tuned enough to where it's not needed? And now, now you're kind of overfitting. I don't know. And it's not, they don't let me know that. Void chain of thought prompts. Since these models perform reasoning internally, prompting them to think step by step is unnecessary. So that is kind of interesting. It's what they said above, but now this time they mention actual chain of thought. Maybe they are just using chain of thought. What they're saying here is it's unnecessary because we're already doing it. So that's kind of interesting if they are actually doing just chain of thought. If I had to guess, they are. It's one of the frameworks that it allows you to be most general. Like some of the things like tree of thought and plan and execute, they require so much prompt engineering to make them sort of really good in a specific domain that it's hard to like generalize them into something like this. Whereas chain of thought, considering all you do is you just say generate a thought bubble before you respond, is very straightforward. And while it might not have the top end accuracy that tree of thought or something like that has in specific domains, it's much more general, much more easy to use. And so, a wide range of use cases like OpenAI sees that might work pretty well. But that's interesting that they mentioned that. Use delimiters for clarity, use delimiters like triple quotation, XML tags, that indicates inputs the input. Interpret different sections appropriately. That is a weird thing. I haven't seen something like this written about before, using delimiters like, XML tag, quotation, section titles clearly indicate. That's kind of interesting. I don't know why that's different for O1 versus other models. I wish they would have said like, hey, with these changes, XYZ and O1, this is why delimiters should be used. They're probably not going to give us that because they don't want to really make the reasoning logic public. But that's kind of interesting that they point that out. They don't usually point that out for some of the other models. Just something to think about. Limited additional context in RAG when providing additional context or documents include only the most relevant information to prevent the model from over-complicating its response. That is something you do see with chain of thought and some of the other plan and execute, you see that as well, where if you pull in too much context, when you go to ask to generate a plan or to think about it meaning, use the chain of thought, create a thought bubble, it generates too much information because it just focuses on all the context you give, regardless of if it's relevant or not to the RAG query. And so you'll see it just generates too much information that is not relevant. And then in your next step, so you generate your thought bubble, in your next step where you say, hey, look at the thought bubble above and generate a response, it takes that at face value and generates an answer that just provides too much information or information that's not incredibly relevant. So that's fairly standard with a lot of RAG pipelines that use chain of thought and things like that. Okay. Other than that, I'm going to leave this here. I want to take a look at some examples of how this model performs on specific tasks compared to the other models. I think that's going to be really valuable to look at and understand what are some key use cases where this model is really beneficial. So I'm going to hop over there and we will take a look at that, and then we'll dive into some more stuff after that. So let's take a look at one of the use cases here that I want to sort of run through with the different models, see what the outputs look like, and see how the new O1 models perform with this. So here's what we have here. Given the React component below, change it so that nonfiction books have red text. Return only the code in your reply. Do not include any additional formatting, such as markdown code blocks. For formatting, use 4 space tabs and do not allow any lines of code to exceed 80 columns. Interesting. And then we have some code. So first, we're using GPT-4 Turbo. Very nice. Let's run this through. And this is what we get. We've got some code. Very nice. Now I'm going to run the same one on the new O1 model, and let's see what we get. So this is what we see when we come in. As we mentioned, there's no system prompt or anything like that, so it does look a little different. Same input, it's thinking, it's going through, it's reasoning, steps, chain of thought, plan and execute, whatever they're doing back there, but it's going through that process. And as we mentioned, this is something that really should only be used in reasoning related or very complex tasks due to what you can see here, which is that it is slower. So a couple things to note. You can see it does look different, which is what we would kind of expect here. So let's go back over here. Let's see what we've got. For formatting, use space tabs. Do not allow any lines of code to exceed 80 columns. Do not additional, such as markdown code blocks. So this is what we had here for our first one. This is what we have for the next one, that's generated the reasoning. So the first difference I notice is, I don't know what exceed 80 columns means. I don't know how you're calculating columns. If they had said like 80 spaces, that would make some sense to me. But you can already see the first one, this is more of a minor thing, that they allow this to be longer than they do here. They try to focus more on tabs down instead of out, to try to make sure that we don't exceed 80 columns in that regard. So that's sort of the first one, kind of a minor thing. I might have the idea of columns wrong, so that part, that's my interpretation of what they're talking about. I would call it 80 spaces. They call it something else, perfectly fine. So that's nice. This model, wasn't really able to do that. The code works. The code is fine, but the rules and the regulations and things like that we included, struggled with that one. Now here's the big one. This is one of the ones that was most interesting to me. So you see the code. If the book.category is, and it doesn't actually generate the, it doesn't regenerate the enum for the books, which is fine. But if book.category is nonfiction, we set color to red. If not, we set it to black. And you can see here above, here is the constants that we have. Very nice. Let's look at this one. Book.category equal to nonfiction, set it to red. If not nonfiction, we don't set it to anything. And this is a minor difference, but really does a good job of showing the ability to really follow instructions. I didn't say that when it's not nonfiction to do anything. I didn't say to set it to black. I didn't say to do anything with it. This one follows that a little bit closer. I'm guessing due to the reinforcement learning, an example of a reinforcement training example here would be if they generated this, we gave it these rules, it generates this output. Our follow-up would be, that's not right. I didn't say to ever use black on the non-nonfiction books. And then it would try to regenerate and go from there. This one follows that instruction. I didn't say to do that. The model is able to take that more into account and really understand the reasoning and instructions to create an output that further follows what we have. This code works. And with GPT-4, that would be fine. The code works, but it's not exactly what I specified. The rules I set out to achieve were not exactly specified. You guys will see me all the time on this channel. I talk about goal state output definition, which is the model's ability to understand what it means to be successful for your specific use case, right? When we're talking about generating summaries, what does a good summary look like for you? Not what the model's interpretation of that is, what it means for you. We talk about generating a legal contract, what it means to have a good legal contract for you, not the model's underlying training, not the model's underlying representation of what that means for you. And things like this show a higher level of goal state output definition, understanding, and ability to work on. So this was one of the most interesting examples to me when I actually ran it through. It wasn't even something when I first ran it I thought about. I looked at that and I was like, it's fine, it works. Then I sort of looked at the other one and I was like, it's fine, it works. When I looked at it further, I said, I see the difference. I see the attention to detail based on what I gave you. Had I said, to choose a different color or whatever when it's not nonfiction, it'd be fine. This shows a different level of detail, a different level of understanding how to generate outputs that are successful for me. So this is the first example. I was very excited to show this one because I thought it did a great job showing something that I chat about quite a bit. Let's take a look at some of the other ones. So here's another use case I wanted to take a look at. I pulled this from one of the cookbooks that OpenAI has for their O1 model. The user query is, what are 3 compounds we should consider investigating in advanced research into new antibiotics? Why should we consider them? And it gives an answer here that we will look at. As you can see, I asked GPT-4 Turbo the same question. The first difference is they actually list different compounds. So this one's the same, and then I think these two are different. Let me make sure. Yeah, so that one's different. And then I think, was that the second one? No, that's different as well. So the first one is the same. The other two that they suggest are different. So that's sort of the first difference. I'm not an expert at all on compounds or anything like that, so I don't know if one list is right or one list is wrong. But what I was very interested in is the format and the style that the model is able to present an answer with compared to what we asked. With these models, being more focused on, human feedback-based reinforcement learning, it should read in a style that fits a response that a human would want a little bit more. And so we can see here with GPT-4, it lists the 3 different compounds. It says when they were discovered, what it does. There you go. It gives a little bit of info on why, we asked why should we consider them. It gives a little bit around that, which is nice. Here, once again, we get another one where it sort of explains what it is, what it does, and then, one line on why we should investigate it. And then here again, this one it's 1 sentence, it's longer. Some more information about that. I actually think, no, never mind. Yeah, so it gives us 3 of them, gives us some information. And then it gives us like almost like a summary of the why. So we have that why question. It's almost like a summary of that why question. And kind of like a, for all of them, which is kind of interesting. So that's what we get for this one. I think it's fine. It's a pretty standard GPT-4 response. I think if you wanted something more, you'd have the prompt for a little bit more. But that's perfectly fine. So let's take a look at what O1 gives us. So same question here. It gives us like a little introduction thing like we saw before, which is fine. Now this one does a little bit more of a structured format. This was the first thing that I recognized and realized that the format and the structure reads much nicer. It's not just a paragraph with a 1 sentence for the why. It's got background information on the compound. It has a whole section on why to consider it. So it understands, that this is kind of a 2-part question. So first you need to identify the compounds that are worth doing it. And then why, give a why for each of them, right? So that's a pretty good understanding of that this is kind of a 2-fold piece here and that we do want both of those pieces. So, then why we consider it. It gives us an implication for research as well, which is kind of interesting. It's fine. We mentioned, advancing the research. So I'm not surprised that's there. That's kind of interesting. Same idea here where we get some background information. And then, we got set into this kind of this, multiple parts of the why. This is where we get a little bit longer response here. Implications, looks fine. And once again, background, the why, and then we go from there. And then it writes a conclusion as well, like we saw above. It's a little bit longer. Which is fine. You can take that how it is, but you can see the difference between these where one is, smaller, shorter, a little bit more straight to the point, not as focused on providing a full, sort of expansive answer, which you usually have to prompt for that, or, you would see that sometimes with chain of thought. Like if you had a chain of thought, and if you did this with a chain of thought question, you put this in, and you ask it to generate a thought bubble before it does that, you would want that thought bubble to say, hey, these are the 3 I want to talk about, and I should break them down into this style. Like that's what you would get. Like when you do chain of thought for summaries, you get like a similar thing, which is like, hey, I should talk about this, I should focus on this, and I should write it in this style. Like that's very common sort of chain of thought for summaries. So I'm, the ability to do this here with the sort of research tokens or whatever that is, very much the same on that regard. So that is nice. It does give a more extensive answer, which is the same sort of thesis when we looked at the difference between models like GPT-3 and then GPT-4 or GPT-2 to GPT-3. You saw that the model's ability to go in depth and expand on things went up quite a bit. That was one of the key things that happened with those models as you continue to make models larger and give them more training and fine-tuning, especially once we really started to introduce reinforcement learning at the scale. This is the type of thing you saw there. So I want to look at one more use case around a domain that I know really well, so I can speak very highly on it. I'm gonna hop over there and we'll rock and roll. So I want to take a look at a use case that I am very familiar with, which is legal text summarization, legal document understanding, things like that. Want to run a couple different tests. I pulled this from one of the legal document data sets that we have. It's just some pretty standard legal text. So let's run something and see what we get. When we just ask for a general summary, I kind of want to know what it looks like as well. Above. Document. I'm starting with GPT-4 Turbo. We'll run the usual one, the 01 as well at some point. Start this. Cool. So document. So this is an abstract summary. Note issue then where supposed to pay blah, blah blah, some of that with interest rate, full payment of the principal accrued blah blah blah. Notice of protest, last the extension payment deadline. You were my last amount. Okay. Let's see what we get with. So it's a fairly straightforward summary. I don't really see anything I don't like, or anything like that. But that being said, I don't really know the document. So let's see what we get over here as well. I guess I'll put everything because we don't have. I guess I'll put it all here. We don't have system prompts, so we're gonna put it all here. And we'll see what we get. I'm just reading the document while this thing runs. Oh, there we go. The document, no, which promise to pay. Principal amount with accrued interest. No. Waive such payment notice. So this is fairly standard. I don't think this piece existed in the other one. No, it didn't. They mentioned it's governed by laws in Ohio. It doesn't mention that part, which I don't know. It maybe you find it relevant, maybe you don't. I guess in a legal setting, you probably do find that that's what you would consider maybe like a named entity that you care about. So it's interesting. Additionally, the document specifies the information found in the note remains valid and enforceable as an invalid provision were not included. Is that part okay? Document states maybe they're still valid. Okay, yeah, I mean this looks fairly straightforward. They mentioned here it's duly signed. Here they just mentioned the sign. So small language tweaks to try to provide just a little bit of a different level of clarity around the document, which is nice. I mean, we aren't performing a task here that is wildly over the top or something like that. But we do see some stuff here, just small tweaks in some of the language that does provide just a bit more insight that you would maybe want if your goal state output definition included that. So now let's see if we can think of something to really dive in here. So let's try. What type of note was this? What type of document? Placement promissory note. So I'm gonna write the prompt and then I'll explain what I'm trying to do here. So I want to see how well GPT understands not just named entity recognition, which GPT is already incredible at, but when we make it a little more domain specific, which is, key entities just for this type of document, see if that looks a little bit different when we run these two, because now we're trying to say, hey, not only do I need you to understand how to extract key entities, but I need you to understand how to do it relative to what we're trying to do here. So we'll run this here, we'll run out the other one as well. I'll be curious to see if this gives any sort of difference between the two. If O1 understands a little bit more some fields that are very particular to replacement promissory notes. So we'll kind of see what that looks like. Parties involved, that's pretty standard. Principal sum, interest rate, repayment, waiver terms, governing law. This one might be different when we run it, because we know it didn't mention the place of signing before. These aren't really named, well, I don't know, yeah, I mean, some of these are like exact key entities. Maybe I should have called it named entities, maybe then it would just given me like key value pairs, because these are kind of like keys, and then some of them have like a huge value pair, which I don't hate, but I don't know, it's okay. They maybe should have specified that. Some people like their named entity recognition to be just like one word, a key and then like just a few words. Some people like a little bit more of a longer one, which is fine. Replacement of original note. I think it gives like a little thing here. So let's run on the other one. I'll be interested to see if there's any sort of key entities that aren't included. Let's see what we get. So we're gonna grab this. We're gonna grab this. Yeah, we'll try 4.0. I'm kind of curious to see what the 4.0 was just a minute ago, sort of the flagship for understanding and reasoning. So we'll kind of see what that looks like. Parties involved, principal amount, interest rate, maturity date, which we have. Yeah, maturity date, prepayment privilege and waivers, which prepayment waivers, governing law, state of Ohio, replacement note details, we saw those as well. Location assigning, that was one we didn't see with 4 Turbo, that we do see now. Signers, provisions of invalidity, these entities are cool. So this list, although I like it more than the 4 Turbo gave us, isn't as long as this one. I don't think it gives us as much, but I will say that 4.0, like this is more of like when I think of like named entities, this is more of what I think of than something like this, which I don't hate it. Maybe it's just the way that 4 or O1 formatted things. Maybe I just don't like the format. But I don't love like I don't know. I don't really think that reads like named entities. Yeah, which is fine. But it's definitely not as long as the other one. Which maybe you don't, but one of the things that I think in general is going to come out of using these sort of thinking and reasoning tokens is longer outputs. I think that we've seen with all these examples, you definitely get longer stuff when you run it through this, and that's what you see with chain of thought. You see the same thing with chain of thought. When you run through that, you just generally get longer stuff as you generate more tokens to focus on, more information to look at. You get some longer outputs there, and either you like that or you don't, and that's just kind of part of the use case and part of the optimization cycle and things like that. It is generally easier to when you talk about like generating the data going down and condensing down than it is to expand out. Because when information just isn't showing up, there's some sort of gap in knowledge that is missing for the model, and that's something that just needs to be worked through and is a little bit harder than saying, hey, you've got a bunch of information, let's figure out which ones are the most relevant or the most valuable and go from there. It's a little bit easier, so I don't hate that. But other than that, let's see if there's here's something else interesting. Anything you would suggest adding to the I want to make sure I get all my terms right. See, this is always an interesting one to ask GPT. Just because I think that this is something that is very like goal state output focused. Like different lawyers would have a different answer to this question. It really requires a bunch of document and use case specific understanding. Where that's not always as easy to do with a model that doesn't know a bunch about your specific law practice or your specific information or your specific use case. Additional provisions that parties often consider, including strengthening agreement for the clarity of its default and acceleration clause, security agreement, attorney's fees and costs. That's one that you very, very commonly see. I'm surprised it's not included in the original one. Maybe it was just like a chunk of one. But that is a fairly common one that you see there. Assignment clause and governing notices. People always seem to have notices. Late fees. That's what I'm surprised they didn't include in there as well. That's fairly common nowadays to put into a lot of these contracts, just so that stuff is outlined ahead of time in case. Okay, so we get a bunch of stuff. Okay, cool. Recommendation. This is kind of interesting. This is the second straight time where GPT has kind of said like, hey, here's my information, but before you take our advice, like you should consult a real person, which I'm guessing they have trained in for a reason. I'm not surprised that they want to do that just to make sure that everything is okay when people actually use the stuff. But okay. So here's our list. Let's see what we get when we run it on the other one, which doesn't have as much. This is a very to me a reasoning type question. Kind of interested to see what we get there. Oh, okay. We'll start at the top. Default. Acceleration, pretty much the same. Payment instructions. Security agreement. Do we have security agreement? I don't see security agreement. So there's kind of the first one here that we have that's a little bit different. We have and what I like you can see the difference between this and this. Like this just says do it and go from there. This one gives you a purpose and a benefit. Like it's just much more information about the same bullet point. We're talking about the same exact bullet point here. It's just much more information, much more context for the why behind what we're trying to do. I just really like that. Assignment, we saw that. Notices, entire agreement, amendment. We didn't see amendments. The modification clause. Yeah, it's the same. Dispute resolution, confidentiality. Dispute resolution. Yeah, so they on this one they mentioned signatures. Well, counterparts. It's the same. Modification, entire agreement. So I mean, you can already see how it's just a more complex. Like here, notices. Specify how notices should be given and which addresses. Something as simple as that. Like notices is such a simple part of contracts. That's what we get. And maybe that's fine, like it's very use case specific, like maybe that's a perfectly fine response. But if you want the additional level of information, this is what it looks like. It gives us the purpose, gives us the benefit. It's just another level of information behind that I think you're gonna see kind of across the board with O1. Like I said, some use cases, who cares? Doesn't matter. Some use cases going to be very relevant and very valuable. So I'm very happy to see that. I think that it a good way to sum it up is the model defaults to additional context. Instead of trying to prompt and pull that out and go from there, it defaults to that, which is very nice. It makes it much easier to prompt. It probably makes it, if you were to take some of these use cases and really expand on them and really get in depth and really complex, if your baseline starting point is higher, then you're going to have more success. It's just going to require either less prompting or the same level of prompting and be able to go from there. So I hope you guys enjoyed looking at the O1 models. I hope that you guys can test it out, play around with it. Let me know in the Discord how it goes, any questions you have, anything like that. Would be more than happy to help you guys write some of these prompts and implement these in their use cases. A couple of things to think about. Think about the speed that it takes to run this model compared to the other ones. Think about the additional code context and pricing around that as well. And think about generally you're going to have a little bit less stability out of the box with some of the responses you get, as it's providing more information. And so you need to figure out if that's perfect or if you need to whittle that down a little bit. So definitely get your hands on this, definitely play around with it, and we'll see you guys in the next video.